Chair, Chairman of the Zero and a member of Zero, all of the experts, ladies and gentlemen, good afternoon. I think this year the theme is the innovation. So me and Mr. Robert were from the management innovation and the architecture innovation and the construction innovation and the technology innovation to explain how can we build the CITIC Tower. So I think the CITIC Tower, many people have visited them. The name, local name or famous name is China Zun. So this figure, I think, you have this paper. You can know about this building. So I do not waste the time. So concern the CITIC. You know, the CITIC group is a great for landmark of Beijing. Since 1955, in Beijing, the first international laborers office in Beijing is built by CITIC Tower, CITIC Group, in 1955. It's in, you know, in Chang'an Street. And the third one is a Capitol Mansion. It's completed in 1991. In that time, you know, this building is the highest building in Beijing. So third one is Nation Stadium. Everybody know it's for Olympic game. In first Olympic game in China and Beijing. So the last one is a China Zun. It's completed in last December. So before we start the construction, we have thinking about these 4 questions, ask ourselves. Because we know all of China, the high-rise building, most of them, the construction period are more than 10 years. So how can, in China, the management system, we can short the construction period? How can we find a way? And the second thing is quality, speed, and cost. The 3 of them always, how can make a balance? How can you get high quality, high speed, and reasonable construction cost? And third one is also unbelievable. Our building only have 11,478 square meters. But the base of our building also is 11,478 meters. So no spare phase, no prepare phase for construction. But we create the record at FAR is 38. I think in all the world, no other high-rise building can be 38 to 1 for the FAR. And also last one is we got the land in December of 2010, and we hand over to start to prepare to management the project in 2011 October. Then we start construction in July of 2013, and we completion them in last December. So the construction period only 65 months. This is recorded. How can we create it? So I just sense from the management system and the technology system, the innovation to explain our building. So for this picture, you know, in all of the constructed or completed high-rise building in China, the average speed every month around 4,500 square meters per month. But CITIC Tower, we have reached 7,723 square meters per month. Of course, here you see, oh, there are another one, already over than 7,000 square meters per month. This is the Shanghai World Financial Center. This building also under my control. I spent 6 years there, since 2003 until 2008. But why they can quite than CITIC Tower? Because the engineering. They started engineering work in the 1994. Construction started from 2004. So that means the owner, they have 10 years to prepare to make the engineering work very detailedly. So when I took over, then we can go fast, very fast, only 42 months for construction. So that means the engineering was very important thing for the construction or develop the period culture. So that means we only use 70% time than other average of the high-rise building in China. Then how can we got this speed and keep the high quality? I think from this you can know in the traditional way to make develop of high-rise building, we need 124 months. But CITIC Tower, we only use 93 months. That means we save 31 months time shorter than other building. That's easy to calculation. Until December of last year, every month my interest will pay more than 100 million. So that means if we short 31 months, then we save more than 220 billion. Sorry, 28 亿, that means 280 million. So then this is a process for design, for the approval, for construction, for electrical, mechanical installation, for decoration work. So that's we can early, in normal, the traditional, we need to talk about 3.5 years to prepare project, to engineering, to get approval, then can start construction. But in the under our control, we only took about 1 year, then we started to construction. So later on, I can tell you why we can do that this way. Because I told you why we should control the time shorter, the enterprise. So for the overdeveloped, they want shorter and shorter. So because the money put in the project money is too high. For example, for China CITIC Tower, we already pay 14 billion RMB. So in last year. So every year, how much interest you can make calculation. Then, so one of the design system involved innovation is that we collect, we make the design concern. In the traditional, the foreign design, they finish the conceptual design and the primary design, then the owner will be bidding. Then choice domestic design form. So they waste time there because the domestic design, they are waiting because when they get a win, then they start work. But in the CITIC Tower, we make the design consortium. So ask the domestic design studio early to enter, to know, to understand the foreign designer, the idea. So we fill the gap for the design. Of course, I'm very thankful for KPF. So, you know, in the 2013, we have signed contract with 5 the designer and the main constructor. So this is, I think, is a very important thing matter. And also for the constructing system, also the management for constructing. In the traditional, in China or in the world, there's only one main generator. Then everything under the main contractor control. But the problem in China, according to the law, we have no general contractor. Our license in China, license only construction general contractor. So construction general contractor and the general contractor are different meaning. So normally, the steel structure, the structure contractor, they hold the power. They hold the resource for construction. So innovation, we do the dual general contractor. One hand, they only do the steel construction and the curtain wall. Then we put the mechanical, electrical engineer, the contractor, give them same labor. Then we put them together to thinking how can we short time. Okay, here I think for me is also important thing is we chose a new technology, new machine. Until now, I would like to say I was very thankful for CTBUH because in 2012, I participated in the annual meeting in Chicago. In that conference, I know they have one of technology is job lift. The job lift can settle the problem, the main problem for the high-rise building the transport problem. But for this matter, you know, we additional pay 36 million RMB for the contractor. I said to them, you should charge this technology. Otherwise, I will not pay you. Because we make calculation. There's 4 job left, equal 40 normal construction elevator. So give the contractor very good condition to go faster. Concern the job left. Later on, the one is the expert from the Kohn, he will give you more detail. And all other the innovation for technology is the firefighting system. In CITIC Tower, we do the pulmonary the firefighting system with the temporary pulmonary firefighting system joined together. So we save many time for the destroy the pulmonary firefighting equipment and give the installation work early and give the decoration work early so it can make it shorter of construction. This is the principle of this system. And also, for high-rise building, the efficiency for the vertical transport also a very important figure. So we arrange, of course, the designer help us. We discussing about this. In the CITIC Tower, we have more than 100 vertical elevator and 35 escalator, the elevator. So our elevator length is compared with the building height is 28:1. So this figure can be let you know how can we be fast if the user enter this building. He will spend a very short time to enter his office. So this is the elevator, the arrangement. And of course, we discussing about the building, much thinking about energy use. So for CITIC Tower, you see the energy for HVAC is concerned with we are used 57% for use for the HVAC. But now, CITIC Tower, we save 25% compare with China standard design. And for lighting system, also normally we'll take 20% of this building, the energy. But our design, we use the LED and other technology. We save 15% compared with China lighting design standard. And the elevator also, we chose the high efficiency the elevator. We also saved 13%. For the curtain wall, I mean, maybe everybody know we use a double vertical curtain wall. So for this, we also save 7% of compared with the China designs stated. So, and also we use the Kohn shower system. Make our building design from 78,000 kVA till 56 kVA, 1000 kVA. We save the 30%. So the equipment, we save money. And my money, you can see, so air conditioner, we from the 3.6 thousand, it will be 36 million, down to 27 million, save 26. So if compared with the price of the electricity, every year will be less than, save the more than 10 million RMB. So later on, concern the innovation, concern the architecture, the design will be Mr. Robert will be introduced to them. Thank you for your listen.
Thank you. It's really a compelling story. It's easy to look at the photographs and think of this as primarily a formal exercise, but it has been one that has really been sort of internally driven and parametric in almost every way. And the way that Mr. Wang has led the entire design team is really quite admirable experience that we'll all remember and cherish. The site, as you're probably familiar, is part of the Beijing CBD. It's east of the Forbidden City on Chang'an Boulevard and just east of the 3rd Ring Road. So after the 2008 Olympics, when development was happening sort of randomly in Beijing, there was a concerted effort made to sort of concentrate high-rise development in certain places to remove pressure from the traditional city. So you go from the traditional center to the new commercial one, and the site was chosen because of its relationship to existing and planned subway lines, public transportation. There's the 3-minute sign. We'll see how we do with that. But a sort of remarkable integrated approach, and one that also considers public open space. So the central green space that's at the center of the development is actually part of a necklace that permeates the eastern side of Beijing. In 2010, there was a competition both for the master plan and for the individual sites. The predominant underlying planning was that the tall building was at the center. It's a structure that's not that dissimilar to the broader structure of Beijing, a cross-axis, the main building on center with things developed to either side. And at that time, Terry Farrell's office in BIAD submitted a winning scheme for the competition, which was based on the idea of this sort of hourglass-shaped building based on the China Zun. The Zun is a sort of traditional ceremonial drinking vessel. So I think it's a really compelling story because this is essentially a singular commercial development, but at the same time, it was important to the city that this building represent the larger population, and clearly we all know the role that tall buildings play on the skylines of cities around the world, so this building does come to represent Beijing in a certain way. We came on board at the end of that concept design phase, and the primary question was, how do you take in either stone or bronze inanimate object and turn it into a high-rise, innovative building that's based on how it creates relationships with adjacent buildings and the ground plane. Here's the building. It's a sort of interesting story because that form, which seems sort of random initially, actually allowed for a fairly parametric design process where the shape of the building and the pieces that went into it were carefully choreographed and sort of fine-tuned over and over. Lu Peng from Arup was saying yesterday that they changed their structural model 600 times as we sort of balance the areas within the form. And it's amazing, you would think that maybe the city would sort of focus on this idea and then let the rest of it go. There were a lot of discussions about where the waist of the tower was. We ultimately generated a scheme that was above, where the waist was above the adjacent buildings. That formal exercise was important, but it actually coincided with the internal planning. As you know, one of the greatest challenges with a super tall tower is how you reconcile the core, which is essentially shaped like a pyramid, with the tower. If the tower is simply extruded, you have virtually unusable floor plates below. But so through the hourglass form, we're allowed to, sort of play with the core. The piece that goes all the way through is within the sort of central reinforced concrete or composite core. And then the low-rise lifts, low-zone shuttle lifts, are all comprised in a jacket on the outside. So as they drop off, you get good core to perimeter dimensions in the middle. This also is quite advantageous structurally. You would think that a building like this would typically have a mega column scheme, 8 columns, 2 in the middle, or quarter points of each facade. But the scheme developed, this is the worst seismic zone you can find. So the structural form is more like that of the Eiffel Tower, where the 8 columns coalesce into 4 mega columns at the 4 corners. This gives us great structural rigidity. It also helps us enormously in the way we plan the ground floor. Interestingly, the structural forces or the seismic forces were stronger and more dominant than those in the wind tunnel, but certainly the changing shape of the tower over its height and the curved corners helped in those regards. The site is on again, this axis. There's a cultural building just to the south, which was designed by another firm. The footprint of the site is absolutely tiny. There's only just enough depth for circulation on the site. And you'll see here the ground floor plan where the columns sort of congregate to the corners that opens up the plan, each of the facades. There's no other use on the ground floor other than the office lobby. Here you'll see the lifts that correspond to the outside. So the other conceit was that I wanted to make the building appear like it was floating above the ground rather than being a big, heavy, solid monolith. So you see the curtain wall as it flows out. This allows the ground plane, the public space, to flow into the lobby, visually unimpeded. Here you see the curtain wall flowing up with one of the main entries to the side, and the cable glass wall at the entry, essentially dematerializing as you see it. Inside the space you see out, and then the 4 columns at the corner are these beautiful sculptural forms. Here, the reflection of the canopy above, which obviously provides covered drop-off for vehicular visitors, so there's not an additive canopy to the building. And here you'll see as the curtain wall comes down at the corners, floating above the column, which is absolutely enormous, really almost disappears from view, but a really elegant form. And then on the inside, you'll see the form of the canopy, and then escalators going to below grade, which is where we have connectivity to public transportation, which is at the basement. The remarkable thing about the project is that all of these basement levels are interconnected. There's 6 levels. They were all excavated at once, and those levels provide common services, service drop-offs, parking throughout the site, and then public retail underneath the Central Park. The ground floor, or B1 lobby, so are double-deck elevators home between the ground and B1, so there's a great planning efficiency there. This is the underside. The canopy sort of flows back. The ribs of the canopy flow back into the lobby to form that space, so integrated with the form of the exterior. And the cladding of the exterior is very simple, just a series of vertical lines that help accentuate the flare. Each floor is equally subdivided the same number of times, which added efficiency and economy to the development of the curtain wall. The top of the building, so here's a view of the base showing the scallops of at the entries. And the top of the building, when we designed it, was actually a flat top, and we got a message from the vice mayor saying that the top of the building didn't look Chinese enough. We, after quite a few negotiations, came up with this form, which is essentially a mirroring of the expression of the tower at the base. And I think has its intended effect that that curve at the top sort of matches some of the curves of traditional Chinese architecture, and this idea about a historic center and a modern center entering into dialogue with one another, I think is sort of beautifully conveyed here. The top of the building was designed for an observation deck. It's a sort of public gathering space. It's still in its evolution. There's the building, and if you will allow me, we just have a quick video. So a long story to tell. I hope we cover the high points. Thank you very much.